Hello students, in this lecture we'll take wave equations for free space or wave equation for lossless media. So question is asked, derive wave equations for free space or we derive wave equations for lossless media. So we'll start with this. In previously we have studied wave equations in time varying field. Okay, so we have to consider those equations also here. But for free space, we have to mention free space is a non-conducting medium, and in free space there is a no conduction, that is Jc is equal to 0. Similarly, no charge is present in the medium. So the charge density, that is a volume charge density, rho v is equal to 0. So we have Maxwell's equation in point form for free space can be written as, so del dot d is equal to क्या रहता है generally rho v, but as rho v is equal to 0, mention that equation as del dot d is equal to 0. Then second equation remains same, del dot b is equal to 0. Then third equation, del cross E is equal to minus dabba B by dabba T remains same. Then del cross H is equal to क्या रहता है J plus dabba D by dabba T. But what is the value of J or JC is equal to 0. Therefore that equation, time varying field equation, becomes dabba D by dabba T. So these four equations are important for free space, and in this uniform plane wave equation for wave equations for free space, um, we have to use these equations. So start with the wave equations in terms of E bar. So differentiating equation 4. So what is equation 4? Del cross H is equal to dabba D by dabba T, as JC is equal to 0 we have fill up. So differentiate, that is dabba by dabba T del cross H dabba 2 by D by dabba T square. That is double differentiation. This equation हो जाएगा यहाँ पे. Then changing the order change करो, del cross dabba h by dabba t, ये dabba by dabba t अंदर लिया है. Remaining equation is same, dabba 2 d by dabba t square. But here we have dabba is equal to epsilon e bar, so, and epsilon is equal to epsilon 0. So put that value in this equation. Therefore del cross dabba h by dabba t is equal to epsilon 0 dabba 2 e by dabba t square. So next is we have to take curl of equation 3. So equation third is del cross E is equal to minus dabba B by dabba T. So curl ले लो उसका, that is del cross E is equal to minus of del cross dabba B by dabba T. But we know that relation between B and H. What is the relation? B is equal to mu H for free space and mu is equal to mu 0. So we can represent equation 4 as del cross E is equal to, as B is equal to mu 0 H, ये mu 0 outside ले लो, and remaining term del cross dabba H by dabba T will be there. That is B is equal to mu 0 and this is a H. ये arrangement किया है. Putting equation 3 in 5. So जो भी equation 3 है, del cross of dabba H by dabba T, ये जो value है from equation 3 यहाँ पे fill up करो. क्या है value? That is epsilon 0 dabba 2e by dabba t square. ये value यहाँ पे fill up किया है, mu 0 वैसे की वैसा. Therefore del cross e bar is equal to minus of mu 0 into bracket epsilon 0 dabba 2e by dabba t square. According to vector identity, we have del cross E bar is equal to del dot E bar into del minus del square E bar. So this is a vector identity, and vector triple product in vector analysis we have taken. So direct formula we have taken. Thus equation 6 becomes, so ये जो value है equal to क्या है? Equation 6. Okay, so del dot e bar is equal del dot e bar del minus del square e is equal to minus of mu 0 epsilon 0 dabba 2 e bar by dabba t square. Now from equation 1 we have del dot d is equal to क्या है? 0. but d is equal to epsilon 0 e. Therefore epsilon 0 del dot e bar is equal to 0. Therefore del dot e bar is equal to 0, means this term is a 0. Therefore equation क्या बन जाएगा, minus of del square e bar वैसे की वैसा, and remaining term is the same, that is a mu 0 minus of mu 0 epsilon 0 dou 2 e bar by dou t square. So this is a equation, wave equation for free space. And for dielectric we can represent this equation, that is epsilon mu 0 epsilon 0 is denoted by mu epsilon. Therefore we can, for dielectric we can write del square e bar is equal to mu epsilon da bar 2 e bar by da bar t square, and equation 7 is called as a equation in free space in terms of e bar. So next is a wave equation in terms of h bar. So for a wave equation in terms of h bar, we have to differentiate equation number 3, and next we have to take curl of this equation number 4. So differentiate equation number 3 again, that is a dabba by dabba t del cross e bar minus dabba by dabba t dabba b by dabba t. That is directly we can represent and rearrange the term, ये डाबा बाय डाबा टी अंडर लेके जाओ, डेल क्रॉस ऑफ डाबा ई बाय डाबा टी माइनस डाबा 2b डबल डिफरेंशिएशन डाबा टी स्क्वायर, बट b इज इक्वल टू क्या रहता है अगेन म्यू एच, और यू कैन राइट म्यू 0 एच. सो पुट द वैल्यू ऑफ b here, we'll get equation del cross dabba e by dabba t minus of mu 0 dou 2h by dou t square, or dabba 2h by dabba t square. Now taking curl of Maxwell's fourth equation, इसका curl ले लो ये equation का. So del cross h is equal to del dot of dabba d by dabba t, but d is equal to what is value, d bar is equal to epsilon 0 e bar, and we also know that del dot b is equal to 0. Therefore del dot h is equal to क्या आ जाएगा 0, that is b is equal to mu h. Therefore del dot h is equal to 0. Therefore del cross h, ये वेक्टर आइडेंटिटी अगेन यूज करना है, del dot h into del minus del square h. Therefore ये इक्वेशन को कैसा रिप्रेजेंट करेंगे आप, is equal to ये इक्वेशन, that is a del dot h into del minus del square h is equal to del cross of dabba by dabba t epsilon 0 e. d का वैल्यू क्या फिलअप किया है, epsilon 0 e. Therefore epsilon 0 del cross of dabba e by dabba t. Then next putting equation 3 in equation 5, that is we will get del dot h into del minus del square h is equal to minus of mu 0 epsilon 0 dabba 2h by dabba t square. Okay, तो ये इक्वेशन आया है mu minus of mu 0 epsilon 0 dabba 2h by dabba t square. ये वैल्यू जो है यहाँ पे फिलअप किया है, ये देखो यहाँ पे. Okay, then del dot b is equal to 0, we know that. Therefore del dot of mu 0 h is equal to क्या आ जाएगा 0, and del dot h, ये mu 0 ये साइड लेके जाओगे तो 0 हो जाएगा, del dot h is equal to 0. So del dot h का ये वैल्यू 0 फिलअप करो, we will get equation, this equation, that is a minus of del square h is equal to minus of mu 0 epsilon 0 dabba 2h by dabba t square. And for dielectric this mu 0 epsilon 0 is replaced by mu epsilon. Therefore del square h is equal to mu epsilon dabba 2h by dabba t square. And wave equations in terms of d bar. Wave equations in terms of d bar, we have d is equal to epsilon 0 e bar, and therefore e is equal to क्या आ जाएगा, ये epsilon 0 ये साइड जाएगा, therefore e bar is equal to d bar upon epsilon 0. So putting this value in equation 7, and we will get in terms of e bar, wave equations in terms of, that is a wave equations in terms of d bar we have to find. Therefore wave equation in terms of e bar क्या है, minus of del square e bar minus of mu 0 epsilon 0 dabba 2 e by dabba t square. ये इक्वेशन में जो है e का वैल्यू फिलअप करो, क्या फिलअप करना है, del square d bar by epsilon 0 mu 0 epsilon 0 dabba 2 by dabba t square d bar upon epsilon 0. ये बार का वैल्यू क्या फिलअप किया है, d bar upon epsilon 0. So we'll get uh, uh, equation, this epsilon 0 and this epsilon 0 gets cancelled. Therefore del square d bar upon epsilon 0 is equal to mu 0 dabba 2d by dabba t square. अभी ये epsilon 0 ये साइड जाएगा और क्या बन जाएगा, del square d bar is equal to mu 0 epsilon 0 dabba 2 d bar by dabba t square. एंड फॉर डाइलेक्ट्रिक ये म्यू 0 एप्सिलॉन 0 को कैसा रिप्रेजेंट कर सकते हैं, del square d bar is equal to mu epsilon dabba 2 d by dabba t square. Okay, so this is a wave equation in terms of d bar. So very easy. If we have derived the wave equation in terms of e bar, only put the value of from relation d bar is equal to epsilon 0 e bar, put the value of e bar d bar upon epsilon 0. यहाँ पे फिलअप किया. ओके, कुछ टर्म्स एप्सिलॉन 0 का कैंसिल हो जाता है, ये म्यू एप्सिलॉन 0 ये साइड जाता है. ओके, सो दीज आर कॉल्ड एज अ वेव इक्वेशन इन टर्म्स ऑफ d bar. Then wave equations in terms of b bar. So for b bar we have to take equation 6 and we know that relation between b and h. What is relation, b bar is equal to mu 0 h bar. Therefore h bar is equal to क्या आ जाएगा, b bar upon म्यू 0. सो बी बार अपॉन म्यू 0 ये इक्वेशन में फिलअप करो एच बार का वैल्यू, दैट इज डेल स्क्वायर बी बार अपॉन म्यू 0 इज इक्वल टू म्यू 0 एप्सिलॉन 0 डैबा 2 बाय डैबा टी स्क्वायर बी बार अपॉन म्यू 0. ये म्यू 0 एंड ये म्यू 0 कैंसिल हो जाएगा. ओके, देन अगेन ये म्यू 0 ये साइड जाएगा. ओके, देयरफॉर विल गेट डेल स्क्वायर बी बार इक्वल टू म्यू 0 एप्सिलॉन 0 डैबा 2 बाय डैबा 2 बी बाय डैबा टी स्क्वायर. Okay, so these are the wave equations in terms of b bar. So okay, so in this lecture we have derived wave equations for the free space. So one of the question is asked in exam, starting from Maxwell's equation in time varying field, derived wave equations for the free space. So first four equation we have to write down, that is for time varying field. But in those equation वॉल्यूम चार्ज डेंसिटी इज इक्वल टू क्या रहता है, जीरो. देयरफॉर डेल डॉट डी इज इक्वल टू जीरो, डेल डॉट बी इज इक्वल टू जीरो, डेल क्रॉस ई इज इक्वल टू माइनस डैबा बी बाय डैबा टी, एंड डेल क्रॉस एच इज इक्वल टू जे सी बाय डैबा डी बाय डैबा टी. जे सी क्या रहता है, जीरो. तो फोर इक्वेशन आपको मिल जाएंगे. देन कुछ इक्वेशंस का कर लेना है, कुछ इक्वेशंस का पार्शियल डेरिवेटिव लेना है, एक दूसरे में इक्वेशन आपको फिलअप करने हैं, एंड वी हैव टू डिराइव in terms of DBEH form. Okay, so these equation we have to derive. So practice for these equations. Thank you.